Alright folks, here I have you a crazy type problem. Here we're trying to calculate the percent abundance of two isotopes of an element from another planet. Okay, this element is fictitious, but it's to help us to try to figure out how to calculate the percentage abundance for two isotopes that we know their atomic weight. Okay, meaning we know their individual masses, but we know what they should equal in the end. Okay, so let me go ahead and show you how to start this. Basically, we're going to try to start out like we did in the previous problem of dealing with isotopic abundance, or percentage abundance, however these problems are labeled. But anyway, what you do is you make a list. We know we're dealing with an isotope 35 of Mi. And we know that the other isotope of Mi is 39. Okay. We know that Mi itself has an entire total mass of 35.9826. Okay, but this number is gotten by multiplying these two other individual atomic mass units, well, excuse me, in this case grams per mole, by the percentage abundance, which we have no idea what that is, because that's what they're asking us to find. Okay, so basically all that you need to do is just this. Okay, go ahead and write down these masses down next to the Mi35 and the Mi39. So basically Mi35 would be 34.9567. Okay, and the Mi39 is 39.0095. Now I'm saving some space here, so I'm just going to write grams down instead of grams per mole. Okay, now normally is the time that we would take this number and multiply it by a percentage. Okay, so like say 70%, but the problem never mentions percentages. Our percentages are unknown, and that's going to be a problem later. Okay, so basically we got two percentages that we have no idea what the answer is to. Okay, and somehow we're supposed to multiply them together, okay, and get an answer, one up here, and multiply this unknown percentage by this number, get another answer up here, and somehow miraculously we add these two numbers together and we finally get this number, this 35.9826 grams. See, that's a big problem. The reason why this is a big problem is we don't know the percentages. So basically we have two unknowns. Well, we know this. We know that our percentages have to add up to 100. That's good. 100% written as a number is written as the number 1. If it was 200%, it'd be written as the number 2. If it was 400%, it'd be 4. If it was the number 550%, excuse me, if it was the percentage 550%, that'd be 5.5. Well, luckily, the percentages that we need just deal with 100, so that's the number 1. Now, you agree that both of these percentages are unknown. So what we need to do is we need to start one of them out being an unknown variable, meaning some letter. Let's use X, because that's what everybody always wants to use for an unknown. If you want to use the letter N, use the letter N. If you want to use the letter P, use the letter P. I'm going to use the letter X. Okay, so I'm always just going to put the X in the top one. That's just my rule. I'm always going to do that. If you want to put the X down here, that's fine. You got to start somewhere with the unknown X. Okay, so I'll always put mine up here in the top. Okay, now let's think about this. If this unknown percentage was say 70%, we would write 70% in there, but that would be kind of ridiculous because it would make us write it again. We probably would write just 0.7 or 0.70. Okay, that's what you should do. Write it in a decimal form. So meaning this, if this one's 70%, this would be 30%, because you're subtracting 70% from the number 100%, which is the number 1. So basically, this is always going to be written 1 minus x. The reason why this is written 1 minus x is the 1 stands for the 100%, taking away from the percentage of the one that you're trying to find. So the percentage of the unknown is this. And once you get that unknown percentage, you can just subtract it from 1 and get this percentage. Pretty easy, huh? Yeah, but you got to do some algebra skills here, folks. You need to do algebra 1 and algebra 2 stuff. To me, it's just algebra 1. Okay, you have a number times a variable, so it's just the number and the variable. So that gives you 34 point. Sorry, I'm coughing. I've got a cold. 34.9567x. Okay. The distributive property here multiplies this number times 1 and this number times the x. So basically what we have here then is 39.0095, that's that number because times 1 is that number, minus this number again with the variable x. So 39.0095x. Now that looks really ugly, and it should look ugly because it is ugly. But what we're going to do is we're going to write this left to right so it makes, it looks more eye-appealing. Okay, because we need to put our like terms next to each other and stuff, and we don't have that here. But we'll fix that. But let me make sure you understand this. The reason why this is x is I just picked one of the unknowns for the percentages to be the letter x. Okay, and once that is done, the other one will always be 1 minus x, no matter what, because it's got to be subtracted from the number 1, which is 100%. So as long as you know, when you're doing these unknowns, make that x and the other one 1 minus x, you'll do it right as long as you can do your algebra skills of using the distributive property. Okay. Anyway, let's write this left to right. Everything that's up here is on the left side. Okay, so we have 34.9567x plus 39.0095 minus 39.0095x equals that number, 35.9826. I'm not writing the G's down just so I don't have them in there to confuse me and to confuse you as well. Anyway, after this, what we need to do is collect like terms. Now, in order for us to collect like terms, we need to see which ones that we need to put together. Now, I'm trying to use another color here. I've got a yellow. I hope it shows up. What I'm going to do is I'm going to collect like terms. I'm going to collect the two x's together. This x here and this x here. Now, they're still going to remain on the same side, but I'm going to put them together, basically add them together. We're going to get a negative number because we got more negatives here than we do positives. Anyway, you use a calculator for that, just so we don't make a mistake. We have 34.9567 minus 39.0095. Okay, let me make sure I enter that in right. 34.9567. And okay, minus 39.0095x, okay, equals negative 4.0528 plus, now that 39 is still there for right now, 39.0095 equals, now that's still on the left side, equals this 35.9826. Now we need to move this 39 over here. We do that by subtracting both sides by 39. So I subtract, 39.0095. You subtract both sides by that, 39.0095. Anyway, that way the left side will just have this. Oh, I forgot my x on there. Sorry,